Analyzing electromagnetic waves. By the end of this lesson, you should be able to describe the electromagnetic spectrum, state that visible light is part of the electromagnetic spectrum, list sources of electromagnetic waves. A reflexology technique can be used to massage the feet. This technique is also possible by using a wave in the electromagnetic spectrum. What type of electromagnetic wave is normally used in the reflexology technique? How is the television program transmitted? How does food get cooked using a microwave when there is no heat provided? The electromagnetic spectrum is a family of continuous waves varying in wavelength and frequency. As the wavelength increases, the frequencies of the waves decrease. The electromagnetic spectrum consists of radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Radio waves have the longest wavelength, whereas gamma rays have the shortest wavelength. Visible light is part of the electromagnetic spectrum. We can see these waves as the colors of a rainbow. Red has the longest wavelength, and violet has the shortest wavelength. What is your favorite radio station? Do you know what the frequency of the station is? Radio waves have the longest wavelength, ranging from 10 to the power of 5 meters to 10 to the power of -1 meter, and the lowest frequency ranging from 10 to the power of 3 to 10 to the power of 9 Hz. Spectrum. Objects in space, such as planets and comets, emit waves with very long wavelengths in the radio region of the electromagnetic spectrum. For communication purposes, radio waves are produced by oscillating electric current in a transmitting aerial, with frequencies being set. Frequencies that are used for public service broadcasting are long wave, LW, medium wave, MW, short wave, SW, VHF, and ultra-high frequency, UHF. The long wave, LW, or low frequency, LF frequencies range from 3 times 10 to the power of 4 to 3 times 10 to the power of 5 Hz. The corresponding wavelengths for these frequencies are between 1 times 10 to the power of 4 to 1 times 10 to the power of 3 meter. The medium wave, MW, or medium frequency, MF radio frequencies range from 3 times 10 to the power of 5 to 3 times 10 to the power of 6 Hz. The corresponding wavelengths for these frequencies are between 1 times 10 to the power of 2 to 1 times 10 to the power of 3 meter. The shortwave SW, or high-frequency HF radio frequencies, range from 3 times 10 to the power of 6 to 3 times 10 to the power of 7 Hz. The corresponding wavelengths for these frequencies are between 1 times 10 to the power of 2 to 1 times 10 to the power of 1 meter. The very high frequency, VHF frequencies, range from 3 times 10 to the power of 7 to 3 times 10 to the power of 8 Hertz. The corresponding wavelengths for these frequencies are between 1 times 10 to the power of 0 to 1 times 10 to the power of 1 meter. The ultra-high frequency, UHF frequencies, range from 3 times 10 to the power of 8 to 3 times 10 to the power of 9 Hertz. The corresponding wavelengths for these frequencies are between 1 times 10 to the power of 1 to 1 times 10 to the power of -3 meter. This is a satellite image of sea ice breaking off the shores of Alaska. The satellite uses microwaves. Why? Microwaves can penetrate haze, light rain, and snow. Therefore, these waves are good for viewing the Earth from space. Microwaves have wavelengths between 10 to the power of -1 to 10 to the power of -3 meters and frequencies of 10 to the power of 9 to 10 to the power of 11 Hertz. Do you know how microwaves are produced? The waves are produced by the oscillation of electric current in special valves. Microwaves are used for satellite communication and also for microwave cooking. Two photographs have been taken. Do you notice any differences between these photographs? This image was taken with a special film that can detect heat. Infrared. The infrared wave lies between the visible light and microwave regions of the electromagnetic spectrum. Infrared waves have wavelengths of a 10 to the power of -3 to 10 to the power of -6 meters and a frequency of 10 to the power of 11 to 10 to the power of 15 Hertz. Most infrared waves are thermal. Infrared radiation can be produced by sunlight, fire, or any body that generates heat. Infrared is used in remote controls for televisions and video recorders. Physiotherapists use heat lamps in reflexology to help heal and relax muscle injuries. Why are colors of the rainbow in such arrangement? Visible light are electromagnetic waves that can be seen. Each color has a different wavelength. Visible light waves have wavelengths between 10 to the power of -6 to 10 to the power of -7 meters and frequency between 10 to the power of 14 to 10 to the power of 16 Hertz. Red has the longest wavelength, and violet has the shortest wavelength. Which color has 1. The lowest frequency, 2. The highest frequency? Red has the lowest frequency, while violet has the highest frequency. Why does the sky look blue during the day, but yellowish-red during sunset? Violet has the highest energy, making it most difficult to diffract. During the day, the sky looks blue because at that instant the blue color is diffracted the most, so we see blue sky. As the red color has the highest wavelength, it can still be seen after the sun has set into the horizon. red has the lowest energy, thus it is easily diffracted and spread over the horizon. What happens when light, visible light, is directed on a prism? What happens if a second prism is placed next to the first prism? When all 7 colors are seen together, is white light seen? A fluorescent lamp is used to identify fake money. There are ultraviolet rays in the fluorescent lamp. Do you know how violet rays are produced? Ultraviolet radiation may be produced by any thermal radiation of a source because of its temperature. The sun and an ultraviolet lamp are convenient sources of ultraviolet radiation. This radiation has a shorter wavelength than light and covers the range 10 to the power of -7 to about 10 to the power of -8 meters, and higher frequency ranging from 10 to the power of 15 to 10 to the power of 17 hertz. Why does the cloth seem to glow in the dark? Ultraviolet radiation can make a cloth glow in the dark. The glow is caused by the presence of fluorescent dyes from washing powders, which absorb ultraviolet radiation and then emit light. Is put inside your mouth on one side of your teeth, and X-rays are shone through your jaw, just like in this picture. What are X-rays? X-rays are part of the electromagnetic spectrum. X-rays have a wavelength between 10 to the power of -8 to 10 to the power of -11 meters, and frequencies between 10 to the power of 17 to 10 to the power of 20 hertz. X-rays are very high-frequency waves and carry a lot of energy. They will penetrate most substances, and this makes them useful in medicine and industry to see inside things. Do you know how X-rays are produced? In nature, the sun gives off X-rays. X-rays can also be produced in the lab. An X-ray machine works by firing a beam of high-velocity electrons at an anode. When electrons with enough energy hit the anode, X-rays will be produced. The patient was given a slight radioactive gas to breathe, and the picture was taken using a gamma camera to detect the radiation. Gamma rays have the smallest wavelengths and have extremely high-frequency waves. Gamma rays have wavelengths of a 10 to the power of -11 to 10 to the power of -16 meters, and frequency of 10 to the power of 20 to 10 to the power of 24 hertz. Gamma rays carry a large amount of energy. They pass through most materials and are quite difficult to stop. You need lead or concrete in order to block them out. How are gamma rays generated? Gamma rays are emitted from nuclear reactions. atomic bombs, and explosions on the Sun and other stars. Let's play a matching game. Match the wave in the electromagnetic spectrum.